Okay, so we're going to do a few practice. We have a test. It's probably the hardest test that you're going to have this year. At least it's close. The final might be harder, but that's because it has so many topics. Test is on Wednesday, so we basically have review today, review tomorrow, test Wednesday. All right, so right now on your iPad, I would like you, looking at this problem, to try to figure out the probability. You'll need a calculator to do the division, and I would have one of those out separate on my desk. I'm going to pause while you see if you can figure out which one this is. And don't forget to check and see if there's a given. It says randomly chosen senior, but if you look closer, this information is only about the senior class. And therefore, it's not really a given. So you don't narrow it down. So it's out of 600. I'm going to be helping you with that much. Okay, so where would can't get enough math be? It looks like I see this right here, 25. Should I use that? Why not? So I should use this? You are correct. 75 out of 600. Raise your hand if you had that one right. The vast majority did. Good. Okay, let's look at another type of question. Same chart. Oh, wait a minute. That's just, forget that. That's the same exact question. I'm going to move on to a different type of question. Here we go. You roll one die at a time. I have a feeling some of you are going to be so freaked out from the really complicated probabilities, you're going to forget the easy ones. This is really easy. Use a fraction or maybe even a decimal in your head and get this answer. Sometimes it's just two fractions. What's the probability you're going to roll an even number? All right, now I think some of you are thinking it's a trick question because it says you roll one die. You know what? It is a trick question the way it's worded. It should say, I thought it said roll one die at a time, and my eyes just like filled that in. It actually says roll one die one time. You can't roll an even number and a 3. Probability would be a 0. Okay, sorry about that. But let's say that you roll one die at a time. So your first roll, what's the probability you're going to get the even? And on the second roll, what's the probability you're going to get a 3? That's what I had intended you to be asked here. So the probability to roll an even number, how many even numbers are there? 3 out of 6, chance of that. And then on the second die, you're going to get a 3. What's the probability of that? 1 out of 6. All right, you'd multiply those together and get 3 out of 6 times 6 is 36. All right, let's talk about another die question. You know when you roll 2 dice, how many different things can happen? 36. You need to know that number. 36 things can happen when you roll 2 dice. I'd like you to list all the combos that make a 7. When you roll 2 dice, list all the combos that make a 7. And don't say 7 and 0. It's not possible in 2 different ways. All right, 6 and 1, 1 and 6. 5 and 2, 2 and 5. 3 and 4, 4 and 3. What does that make? Is that it? Is there any more? Okay. So if there's 6 out of 36 possible ways, then that can be reduced to what? So there's a 1 in 6 chance that you're going to roll a 7 when you roll 2 dice. Does that seem likely? Well, it's, I don't know, sort of likely. Is it more likely than some other things? Yeah. A lot more likely than, for instance, an 11. Figure out the probability you will roll an 11. You got it, 2 out of 36. Because the only ways to make an 11 are a what? 5 and a 6 or a 6 and a 5. And so there's 2 ways out of 36, which reduces to 1 out of 18 chance of rolling an 11. 7 and 11 are the 2 we just figured out. And when you roll for the first time, if you roll a 6 or if you roll a 7, or if you roll an 11, you win, but only on the first roll. Every roll after that, the next number you roll is called the point, and that fixes the way the betting works on the table. So let's say that you roll a 7 the first time. You win automatically. Yay. Doubled whatever money you had bet in the first place. Then you take it off the table and you put money back on the table, and you establish a point with your next roll. Let's say you roll a 9. Okay? Then now you can bet on getting a 9 again, or you can bet on anything else coming up. Okay? So if you roll a 7 from that moment on, or an 11, then you will automatically lose anything that's out there. So basically, they do make a 7 a winning and a losing number that way. So on the first roll only, it's a win. Any roll after that, it's a loss. The house wins, unless you bet on 7 coming up. And there's only a 1 in 6 chance of it happening. How much do you bet? You bet any amount you want. But if you bet on a 7 coming up, they will give you what's called odds. They'll give you, let's say they give you $5 if a 7 comes up. You bet $1 and they'll give you $5. What should they really be giving you? $6. But they don't give you quite enough, so that it makes it a losing deal for you to bet on it. Okay, another thing that people like to bet on is a hard 8, it's called. Now, first of all, it messes with your head in 2 ways. Figure out the probability of getting an 8. Figure out the probability of rolling an 8. So there's 5 ways to get an 8. What are they? Say I'd have a 7. 6 and 2. 2 and 6. 5 and 3. 3 and 5. 4 and 4. And do I have to list that twice or not? No. So there's 5 ways to get an 8. 5 out of 36 chance of that happening. But what do you think you have to get in order to get a hard 8? It's called an 8, getting an 8 the hard way. The 4 and 4. What's your probability of that? 1 out of 36. That means that they can pay you odds. So like if you bet $1, what should they pay you if you win? 36. But what do they pay you? Like 30. So people get attracted to that, saying, oh, wow, if they just roll double 4s, I put out $1, and if I win that, I'm going to get, let's say, $30 back. Well, they should be giving you $36 back, because it happens that rarely. But they think, oh, these are great odds. They're going to give me $30 for a $1 bet. Yeah, but you have to do that 36 times before, on average, you're likely to win it. So again, seems like a smart bet. It's actually a losing bet. Yes? Okay, what is the probability of rolling a hard 8, you mean? That's really easy. I can just roll the dice, and I have to roll them 36 times likely before I'll ever get it. So 1 in 36 chance of getting a hard 8. There's a 5 in 36 chance of getting some 8, but that's a totally different bet. The more you do it, the more you're likely to not win. Because I know what you mean. Like if I do it 30 times, I'm pretty likely to win. But then, by the time I've won, I've spent so much money that see, they want you in Las Vegas. They want you to come visit because you feel like you have this chance and you don't. I mean, of course you have a chance. There's a chance. But I get what you're saying, that if you play the game a bunch of times, but the more times you play the game, the law of large numbers is that the more likely it is you will come to the average. And what you should expect is to only win 1 out of 36 times. And if they only pay you $30 when you win, then you're losing a little bit of money every single time you bet.
They probably wouldn't give you $30.
On average.
They'd probably give you
Yeah, they don't want to make it obvious that you're going to lose, though. So I could very definitely see them paying out $30 on a hard 8. I should look that up because I've heard that hard 8 is one of the worst bets you could make. So I don't know what their payout is. Yes? If you, it's a simple statement. If you're ever ahead, you should quit and go home. But the reality is most people come to the casino, and if they win early, it's like one of the worst things that can happen because they don't want to leave because, hey, I just got here. You know what I mean? I spent the time to get in the car, drive out to the casino, and I'm ahead, but I'm having fun, and they want to stay, and so they stay, and if they win early, then they just lose, and then like by the end of the evening, they've actually lost more than they won, and it's best is if you get lucky enough to win something big right at the end of the night, and you're like, I'm tired, and I want to go home, and I just got money, and then that's the people that actually leave with money. If you can be disciplined, though, yes. If you ever won, you should just get out of there. Yes.
Are there people that walk into casinos with calculators, walk around, calculating games, figure out which one's the best?
No, because anybody who's that smart enough to know the odds really well wouldn't be in the casino because everything's a losing bet. Actually, there's one thing that's not a losing bet, and that is order a pop because they'll give you a free pop. It's the only thing that's not a losing bet. Other than that, it's all a losing bet. There's only one bet that even gets close to fair, and that's the certain bet in craps, that game where you roll the dice. There's only one bet, and that's only fair. It's not like an advantage to you. It's just even. It's like betting on heads or tails, and I pay you $1 if you win and $1 if you lose. It's like on average you should just break even. Yes?
So you could just walk into a casino and sit down and drink coffee.
Yes. Eventually they do kind of say, okay, it's time for you to move along now. But they're not even nasty about it because they know if you sit there long enough, you're pretty likely to start getting tempted. You'll see somebody win and you'll be like, well, maybe I should just try one game. And then maybe you win in the first hand and you're like, ooh, this is fun. And then you're sucked in. Yes?
But aren't there some skill games like poker that you can play?
There's some, yes, poker is a skill game, and when it's played in a casino, though, the casino has what's called a rake, and that means that out of every hand you play, they take 10% of the pot, which doesn't look like much because they're like somebody just put in a $100 bet. They're going to kind of sneakily grab some out of the pot, and they drop it in this little box, and it's the house's take on the pot. So they don't charge you to play, but they take a tiny percent. It's actually, is it 10%? It's some percent of the pot. Comes out automatically. So they even make their money there. So the saddest thing is when they have old people who really believe that if they play a machine long enough, like it's due, they really don't believe the whole idea that if you've played a game 100 times, they think it's likely to go. It's like an inch away from going. I just got to play a little more. And so some people actually, some of the old people have been known to wear Depends diapers so that they don't have to go anywhere to go to the bathroom. You can just stay on your little seat and keep on pulling the lever. Sad. All right, moving on. If having a boy and having a girl are equally likely, what's the probability a family with 5 children has 3 boys and 2 girls? All right. So is this one of those kind where we could use a giant tree? Yes, but it would take you forever to make. So instead, set this up using binomial. You are correct. 5C3 is how we start, and then? You got it. Raise your hand if you knew to set it up like that. Good. Then you get binomial, and those will be easy for you. Let's move on. So keep saying PJ on top. And I don't know why. It's a probability thing. I don't know what the J has to do with anything, but okay. A coach is determining the batting order for the team. The team has 9 members, but the coach does not want the pitcher to be one of the first 4 to bat. Please make 9 blanks on your page. This is a problem best solved with blanks because they're going to tell you that a certain spot can't be like normal. Well, as soon as they say something can't be like normal, then you can't use P's or C's to do it. Since they're saying the kid can't hit first, second, third, or fourth, then how many choices do I have for the first spot? And then how many for the second spot? And then 6, and then 5, and then why does it change right now? Because the picture can be in there, and so instead of 4, which it normally would be, it's a 5 again, and then 4, 3, 2, 1. Raise your hand if you get that. Okay, good. Whenever there's like many techniques for solving problems. There's fractions, we did that once. But there's binomial, we've done that. There's a tree, we haven't actually made one yet, but I think you know what they are. There's blanks. So one of the hardest things is trying to figure out which of these ways should I use on a given problem. All right. 9 people in your class want to be on a 5-person bowling team to represent the class. How many different teams can be chosen? That's an easy one, isn't it? It should be. Then it is. So is it a C or a P? So did you do 9C5? You did it right then. Notice this is not a probability. This is how many can be chosen. These are a lot of different ways you could make the team. All right. What if you wanted it to be your 5 friends, you and 4 friends, I guess you'd say. And there was 9 people to pick from. What's the odds or probability it's going to be that team? There's only one out of all of that. Only one team you would want, you and your friends, out of all of those choices. All right, moving on. Card problems. Definitely card problems on the test, so be prepared for that. It's out of 52 playing cards, and they want to know probability, so I know it's a giant fraction, that both cards out of a 2-card game, this is like Texas Hold'em, has 2 cards. What's the probability that both are hearts if the cards are not replaced? Uh-oh! As soon as they say if the cards are not replaced, then that means I can't use my normal technique of like 52, choose 2. You remember what I'm talking about? As soon as they make it different, like weird, then you have to use a different way. Now, I could use fractions, though. What's the probability of that first card coming out to be a heart? That's easy. 13 in there out of how many? 52. And then you'd multiply by the next one. And since they did not replace it, 12 out of 51. There you go. You'd multiply those 2 together. Why? Why? Because as soon as the kid picked the first heart, do you get, if he does not replace that the deck is different now? And therefore it's not out of 52 anymore, it's out of 51. And it's not 12, and there's not 13 in there anymore now, there's only 12. That's why it's that way. Okay. Now, I was tempted to go make one of these, and I could see a lot of kids doing that. 52, choose 2, and then saying both of them are hearts, and then going 2. No, there's 4 hearts in the deck, choosing 2 of them. I could see a lot of people have done that and be wrong. Okay, because it's different. It's a different kind of a question. You can't, as soon as they say that they're not replaced, then the stuff isn't independent anymore, and then it messes things up. All right. I suppose it's humanly possible that this is the same answer, but I don't think it is. We better test that quick, just to make sure, since I'm recording a video here. I don't want to say something that's completely wrong and just gloss over it. We need to have this multiplied out. So somebody multiply the top 2 fractions. Somebody else do this bottom thing. Okay, which way did you do it? The bottom way? I need 2 people to tell me what the answer is so that I can verify that it's not just one person. Bottom one is, okay, then you'd, wait, who says that the bottom, can anybody verify that bottom answer? Okay, nobody else has, have you done the bottom? And was it the same as this? Okay. Uh-oh, I screwed up the number. If you were going to try to do this way, you'd say there were 13 hearts and you're going to choose 2 of them. Sorry. Try it again. Try the bottom again. 0588. Can anybody verify that number? Okay. Is it going to be the same? Okay, so you must have done the top then, Mr. E. What did you get for the top? Holy cow! We can do it that way. Oh, wait. Now there's some people saying it's different. Yes? Oh, if it's only off by .001, it's a rounding thing, so don't worry about that. Yes? Yeah, that wouldn't work. It's either got to work this. You got the same answer? Oh, that's surprising to me. Okay, so I don't even want to say what you said because that's way different, and I'm glad it worked, but I don't want people to start thinking that they should do it that way. It's easier than that. If the thing that threw me off is this whole not replaced. Normally, what do we do in these card problems? We don't do them one at a time. We hand them out like you get all these cards at once, right? And you pick up this pile of 5 cards. Well, this one, because it was coming out separately, it says not replaced, and it made me think it was totally different. And that's the reason I stopped and said, maybe we should check this because it might work. Let me try to get through what I'm trying to say here. If you deal out hands to people, do you get that one of the cards that's in front of them is not going to get replaced in the deck? You know what I mean? When you keep on dealing it out. So it actually isn't something different. It's just saying it different. We never have replaced the cards in the deck. We've always just dealt them out. And so then we are doing it without replacement in the first place. So that's why both of these methods work. There are a lot of problems where more than one way works. I guess this is one of them. I'm glad we checked it. All right, so a more normal card problem. I'll give you another one. See if you can write the right formula. Don't have to get the decimal. There's a lot of different hands in poker. One of them is called Big Slick. That's an ace and a king. And it's in when you're playing Texas Hold'em. And I'd like you to figure out the probability that you get 1 ace and 1 king when dealt 2 cards. It's called the Big Slick. It's a good hand. It's not amazing like ace-ace. One king, 1 queen. Sorry, 1 ace, 1 king. Sorry. It's the same exact equation, but 1 ace, 1 king. So it's 52, choose 2. Remember, what probability always boils down to is what you want over what's possible. This is what's possible. 52, choose 2. What you want was 4, choose 1 of them, times another 4, choose 1 of them. Now, if I wanted to, I could make one last C here, which is optional, but some people like this balance thing. If I take away all the other cards, there's 44 cards left. And how many of those am I going to choose? 0. Now, why is that helpful at all? Because this plus this adds up to this. And this adds up to that. Oh, and this. Sorry. Okay. Get card questions? Raise your hand if you feel like you get the card question kind. All right, good. And then, here is an expected value problem. We've had all kinds of probabilities. This is one of them. And expected value always comes from 2 different perspectives. If you buy the warranty, and there's like, if it's a gain for you, which is really rare, but if you buy a warranty that actually is a $5 gain for you, what is that from the company's perspective? $5 loss. Okay, so it's obviously a direct inverse correlation there. So this is asking about the company's expected gain. Now remember, whenever you see expected, P times A, then add. All right, what's the probability? It's either live or die. What's the probability you're going to live? .007. Good, because the probability, no wait, that's die. .007. The live is, that's really depressing. There are some people that have that because they have like terminal cancer and they're not likely to make it, but anyway. Then the amount you get, now that's not the amount you get, it's the amount the company gets if you live. Now really, you could do this two different ways. You could say they get the money you paid for the life insurance. So you could put the 150 right there. But personally, I'd rather like to say 0. From the company's perspective, if you live, they don't lose anything. But if you die, they're going to lose $10,000. No, 15,000, isn't it? Yeah, 15,000. Then, you got to always look back and see, did I include the price of the policy yet? No, I didn't. And that's really important. This has to come in somewhere. All right, somebody take the .007 times 15,000 and what do you get? 105, thank you. Now, from the company's perspective, is that a gain or a loss? Nope. If you die, they do not make money. They lose money if you die. They are betting that you aren't going to die. So that's negative 105. Add them together, negative 105. Did I just find the expected value? No. What I just found was the fair price for that insurance. That's the exact fair price. So if the price was 105, then you wouldn't lose anything. The company wouldn't make anything either. And that's not how our economy goes around. We want to have the companies make money. So now I factor in they get 150 for selling you this policy, and the net is positive $45. From the company's perspective, they are going to gain money. That's called profit. That's not bad. That's what you expect to happen. Yes? Good question. No, everybody do that. They would be like, hey, I'm going to die. I'm going to buy life insurance now. They'd buy like $10 million of coverage or whatever. Another thing you can't do is buy insurance and then kill yourself. Because there are people that have tried to fake their death even. Like they'll buy the life insurance because they feel bad for their family, but they want to kill themselves. And then they try to fake their death. But the insurance company is really careful. When it comes to paying out like $2 million, they're willing to spend like 5 or 10 grand researching and making sure that the person didn't fake their death. You know what I mean? In faking your death as in not even having the body, they won't even pay out for a long time. Because otherwise you could have just like skipped country and go to Canada or something and act like you died. Okay, so they really don't want to pay those out. But sometimes people have done it where they'll like fake, they'll fake their death like out in the ocean, for instance, and you can't really tell. I mean, maybe they did die, but maybe they're gone somewhere. So they wait a period of time, a long time, and then finally the judge will say, okay, we will allow you to declare them dead, and then the insurance company has to pay.
And then can they like come out and say, oh, I'm not dead?
Yes, if they wait long enough, they could actually get away with it if they wait beyond the statute of limitations or whatever, but it's a long time, so they'd have to go into hiding forever. And even then, maybe the insurance company could sue them after that to get the money back, but then again, maybe the money's already been spent. But yes? What if you have a twin? So you're cooking up the ultimate plan to rob the insurance company? Get your twin. What, are you going to actually kill your twin then? No, don't even. Oh, let's not go there. Okay, there are a lot of interesting insurance scenarios. A lot of money gets paid out by insurance companies to people that faked stuff. Like I work for an insurance company. One of the things they said was they had somebody call up and say, yeah, my car got hit by hail really bad. And they came out and looked at it, and they could tell that it was a hammer, a ball-peen hammer. The ball-peen means that the end of the hammer is round, just like a hail ball would be. But they have ways of telling whether somebody did it with a hammer or whether they did it with whether the hail actually hit the car. And one of the clues is that hail doesn't come from the side. So people will like bang the side of their car And hail comes from the top down. And so, anyway.
I have the perfect plan. Your identical twin had terminal cancer. You buy really expensive life insurance, and then he dies.
And then turn in his body as the proof. Gotcha. Twins, I don't think even identical twins, do they have identical fingerprints even? They do not. All right. Interesting. Do they have the same DNA? So people with the same DNA can have different fingerprints, you're telling me. I did not know that. Cool. All right. This one could be done with a giant tree diagram. Shh. But anytime there's a big tree diagram, you should think, I'd rather use what? Binomial. Because there's only two things that could happen here, right? It either germinates or not. So if it's that, then you can use binomial for it. All right, so this would be a way good time to not draw yourself a giant chart that would have 4 seeds. Each one has, there's 2 choices for each seed, so 2 times 2 is 4, times 2 is 8, times 2 is 16. You'd have to make a tree that has 16 different branches on it. Or you can just do binomial. So, C, how many are there? 4. And at least one will germinate. 4C1 works, but doesn't there some other ones that would work? 4C2 and 4C3 and 4C4. And then all of these have a 0.8 chance of germinating, and then a 0.2 chance of not germinating, 1 and 3. Do you get what I'm doing here? Would there be a smarter way than this, though? You got it. You can say, only thing we're not doing here is the one where it didn't germinate. So I could go, wait a minute, 3 here, and then a 1 here. Let me just finish this. You can either do all of these and add them all up. Excuse me, some of you are still talking and you shouldn't be. And if you'd rather, you could do the one case that doesn't work, 4 choose 0, 0.8 0, 0.2 to the 4. Find that one out, and then do 1 minus that. Because all of these have to add up to 1. When I add all these up, it'll add up to 1.0. So it's either add all of these up, or figure out this one and take 1 minus that. Now if that went over your head, then just do it the easy way. That's not, it's going to take a while. Figure out this one, this one, this one, and this one, and add them all up. That works. Because you'll be happy if at least one, which would be 1 or 2 or 3 or 4 of them, germinate. Don't know. It's a lot of multiplying, and I don't trust anybody to do it that fast. So I'm sure you can do it now that you know how to set it up. All right. Why is there like 6 of those? Okay, Venn diagram. I think we've done enough on Venns that you'll be fine on those. And that's it. What do we have for today? We have 2 things. One is a formative. I want you to do in class right now. It's a Skyward formative assessment. And then I have like a 10-question worksheet that I made this morning, which is a good practice for the test. That's your homework, and it's on Schoology. So start with, go to Skyward and take your Skyward assessment. Then do the 10-question test for practice. The answers are not online. We will grade it in class tomorrow, and we'll get a sneak preview of if you don't study, here's probably how you do. Because if you get 10 out of 10 on my little practice test, you'll probably get 10 out of 10 on the real thing. Or, I don't know, it's probably out of 30. So you get what I'm saying? So there's no answers for tonight's on purpose. So I want to see how you would do without extra studying. And then tomorrow's homework, there's answers for that. Yes, sir? Test is Wednesday, that's correct. So you still have time. If you do have trouble with this tonight, you still have some time to study up on what you don't get.